What's up, guys? Welcome to today's show. So, today we're going to talk about Ethernet and how computers communicate on a local network. So, you have probably heard about IP, the Internet Protocol. But today we are going even lower level than IP. Because IP is on level 3 or layer 3 of the OSI model. The higher the level, the closer we are to the application. And the lower the level, the closer we are to the hardware. And Ethernet is primarily on layer 2. But also layer 1. But we are going to focus primarily on layer 2 today. So, when you communicate through regular mail, let's say we have an envelope, something like this. So this is the back side of the envelope, and this is the front. So the stamp will be up here, for instance. In addition to the actual envelope, we do also have a piece of paper, like a letter, with some information on it. And in order to be able to send this anywhere, we need to write the message on this piece of paper, on the letter, and put it inside of this envelope. And on the envelope's front, we will type in the address to the recipient. And on the back side, we will usually put in the source address of the people who sent that letter. If we are only going to communicate one way, this is not necessary, because if we put this piece of paper inside of the envelope, write the recipient address and mail it, it will reach the end user. But if the user wishes to respond to this letter, we need this source address as well. And why do I talk about this snail mail system? Isn't that a little bit outdated? Well, perhaps. But it's a good metaphor for how this stuff works. So to the right here, I have a network and 3 different personal computers, PC1, PC2, PC3, and above I have written so-called MAC address, or a short version of the MAC address. An actual MAC address looks something like this. So we have a total of 6 different fields, often depicted with a colon in between. And each field contains of 2 hexadecimal digits. And if you're not familiar with a hexadecimal number format, it's like 0 to 9. And then we have A to F. So we can represent 15 different numbers plus the 0. No, including the 0. Anyhow, so this is the contents of a MAC address. And a MAC address is designed so it's globally unique in the world. Every new PC which is manufactured or network card will have one of these addresses burned into the circuit. And you can't physically change the MAC address. You can change it logically, like how your computer represents itself on the network. But the MAC address is unique, and it needs to be unique, because if you connect two computers with the same MAC address on the same local network, it will not work. So how do we manage to create a globally unique address like this? Well, the first three fields is decided by a organization, a global organization. So if you start a new company which produces network equipment, you will be assigned one of these. And those other three fields you can pick as you wish, as long as they don't collide with anything in your own organization, so to speak. Usually maybe the first network card produced will have all zeros like this, and then you count up to 1 and 2 and so on. Or you have some other way of doing it, but it needs to be globally unique. So a MAC address is like an IP address, but the IP address is for transporting packets globally around the world on the internet, whereas the MAC addresses are used for communicating on a local network. So these two standards coincide and cooperate a little bit, but without MAC addresses and a protocol like Ethernet, you will not be able to send packets locally on a local network. And the internet consists of a lot of different local networks like this. And these are connected through routers, and all of these local networks create the internet together. So to my right here, I have this sample network, and I have shortened the MAC addresses, as you can see, to only 2 fields, and that's only because it's easier for me to write. But when I say like AAAA, I mean a real MAC address, 48 bits long. All right, so if we have this network, how do we connect these computers? You might think through a router, perhaps, but that's not really true, because a router operates at layer 3, and we are on layer 2 at the moment. So if we have a router here, which might be connected to this local network, this is the edge of the network. So this port on the router is part of this local network, but on the other side of the router, there's another local network. So the limit of the local network goes where the router is. So how do you connect these? One way is through an older piece of network equipment that you might have heard about. It's called a hub. They are rarely used nowadays, but they are a good way to start thinking about this stuff. So a hub is like an extension cord for electricity. Everything which is sent into one of the ports on this hub is being sent out to the entire local network like this. And this makes it very easy to produce one of these network devices, and very cheap. and it's quite simple, not very complex system. However, there are a couple of downsides. One is security. Since every frame, it's a network packet on layer 2, it's called a frame. Each frame is sent to all the different nodes in the network, which is not very safe. Because it would be very easy for one of these computers to listen in on the network communication when it's sent everywhere. So that's one thing. And the other thing is, let's call it speed. If you need to send each network packet to every node on the network, maybe in a network like this, where we only have like 4 different nodes, including the router, it's still viable. But what if you had like 20 or 50 devices on this network? The speed will go down very rapidly as new network devices gets added. So that's why these types of hubs are no longer used. But during the 90s, this was the primary way of connecting local computers, at least on home networks. So what do we use instead? I think you know the answer. This is a switch. A network switch is a more advanced hub in a way. It's still connecting computers at layer 1, layer 2, but it has some intelligence. When one of these computers sends a network frame, it will look at the envelope, so to speak, and learn the different MAC addresses on the network. And using that knowledge, it can send, if this PC1 wants to send a network frame to PC2, for instance, it can do so without it going to the router or to PC3, since this network switch knows all the MAC addresses on the network. Let's take a closer look at how we can create one of these frames. So when we send a frame on the network, we need to package it in some kind of way which all of these nodes can agree on. So there is something called PDU, and it stands for Protocol Data Unit. And it's a way of packaging information which works on all of these different layers. So the exact PDU format will be different on layer 3 and layer 2, etc. But it has the general PDU format is still similar, so to speak. It's always consisting of 2 different fields. We have the header and we have the data field. So the header is the envelope, so to speak, and the data field is the letter inside. The header contains all the addressing information. On layer 3, for instance, it might contain IP addresses, and on layer 2, it might contain MAC addresses of the source and the destination. So using this PDU format with a header and data, we have some consistent way of talking about these things among the different protocols on the different layers. So, for instance, since we're talking about Ethernet, I'm going to show you how one of these frames look. So we have a source field, we have a destination field, and we have a data field. And there are different versions of Ethernet and different ways of representing it. But these are the general parts of it. Usually we can include one more field, which is, it can be called the type field, for instance, or the protocol field. And this contains some information like a value such as 0x0800. If this data field contains an IP packet, for instance, or it might contain something like 808 if it's an ARP packet. And that way we know how big this data field is, and we know what to expect. All right, you guys, welcome back. So if we remove this type field and focus on the other parts of the Ethernet protocol, and now I'm talking about only Ethernet, no IP or anything else. So let's say PC1 here wishes to communicate with PC2. And we need to take one thing into account, and that is that PC1 knows its own MAC address, but it does not know anyone else's, not PC2, not PC3, not the router. And let's say these two have not communicated previously. So let's say PC1 wants to say hello to PC2. So the data field will contain the hello message, and the source address is of course PC1's MAC address. So let's put AA in here. But before we can send this, we need to put something to the destination. And what do we put there? Remember that PC1 does not know the MAC address of PC2. So in this case, we put all Fs. So I'm only writing 4 Fs here, but it's a full MAC address of Fs. So what is it? 12 Fs or something. And this is called a broadcast frame. And PC1 will send this to the switch, and the switch will send it to every single device on the network, like this. And that's the purpose of a broadcast. So if it does not know the destination MAC address, it's going to send it as a broadcast. And PC2 will receive this whole frame, the message as well as the source and destination addresses, which means that PC2 now knows the MAC address of PC1. So it's going to save that inside of a table. So we write down AAAA and PC1. And this is called the MAC address table, or sometimes it's called the CAN table. Often when we talk about routers, because routers have a memory chip which is called a CAN, where it stores this kind of stuff. So it's a term which is widely used. All right, so let's now say that PC1 I mean, PC2 wishes to respond to PC1. So let's say we want to say hi there. And in this case, PC2 is going to put its own MAC address as the source, which is CCCC. But this time, PC2 knows the MAC address of PC1. So this time, we can put it inside of the destination field like this. And when we have the MAC address in the destination field of an end device, this is called a unicast frame. And what will happen is this is going to be sent to the switch, and the switch is going to send this frame to PC1, but not to anyone else. And this is the most optimal way of communication. All right, so this was a little crash course into the Ethernet protocol, and now you know enough to code this stuff in C. But if you feel that something is not clear, or if you want to learn more about this stuff, I recommend my book, The Foundation of Network Technology. Because in chapter 2, you will learn all of this. And this is the Swedish version of the book, by the way, but I will provide a link to the English one. And here you will know everything about MAC addresses, how the communication is on the network, and all that stuff. And if you continue on to chapter 3 about Internet Protocol, you will also learn how these two protocols work together. So thanks for watching. Thanks for today.